Okay, thank you very much, Diana. Great to be here with you all. I will try to explain to you very simply using 5 slides how a seasonal forecast is made. Okay, so I'm going to share my screen and just tell you how forecasts are made. So the first point I want to make is that making a forecast for the next days, the next weeks, or the next months is similar. It's done in a similar way today. The only difference is that if you want to do a forecast for months ahead, because you need to do a lot of computations, clearly you cannot use a model, which I will talk about, which is as detailed as the model which I use to predict the weather for the next days. So you cannot expect that forecasts valid for months ahead have the details and are as accurate as the forecast valid for a few days ahead. So this is the first point I want to make. Okay, how are these forecasts made? There are a set of ingredients, 4 main ingredients. The first ingredient is science. So we scientists study the physics of the atmosphere, of the ocean, of the land, and we try to design models that simulate what's happening. For example, we try to simulate how clouds are formed. They move, water condense, and precipitate. And once we have understood science, we build models. Models are essentially software, pieces of software, very complex pieces of software, millions of lines of code, which are trying to solve the equations that we write that simulates the real processes. Clearly, to then do a forecast, the first thing that we need to know is how is the weather today? And we need to know it over the whole globe if we want to predict the weather for the next weeks and months. Why? Because the weather moves, air masses moves mainly from the west to the east. So if you want to know what's going to be the weather in Kenya in 7 days, you need to know more or less the weather everywhere over the globe, okay? So we need observations. Observations, models, science. We use them together, we build these models, we can use supercomputers to generate the forecast. Every day, the National Met Services generate forecasts, some of them twice a day, some of them 4 times a day, with a different forecast length, some only for a few days, some for weeks, some for months, and then they build the products, okay? So when I talk about observation, I mean mainly observations from satellites, okay? Here you see an image of the observation taken by 5 geostationary satellites. So there is one, for example, Meteosat 11, which looks down over Africa, for example. As you can see, the satellites cover some regions, not the whole globe. So some regions are observed better than others. Every day, we collect about 600 million observations. 95% comes from satellite. The others comes from stations on the land, ships, buoys, and so on, okay? So these are the observations. The models try to simulate all the process, all the important processes that affect the weather. The interaction between the ocean and land, the interaction between the air that flows over land and vegetation and the mountains, clouds, sea ice, and so on. And the models are based on the equations of physics, okay? Clearly, we cannot solve them with a pen and pencil. We need to, as I said, we write very detailed models. We solve them on a computer. The computer sees the atmosphere, the globe, as a mesh, as a grid with 1 point every 10 kilometers in the European Center models, 20, 30 kilometers in other models. So there is 1 point every 10 kilometers. There is a set of layers in the vertical. So what the model that we're using tries to do is simulate the weather at each of these points. okay? Once forecasts are made for the next days, weeks, and months, forecast products are generated, like the ones that I'm showing. Here on the left, for example, you see the forecast that was issued on the 8th of October for Nairobi. So today is the 13th, and the forecast was predicting temperatures slightly above average, a little chance of some 50%, 75% chance of rain, for example. Then we produce maps like the one that you see here on the right. It shows the weekly average precipitation for next week. And then if we go further into the future, other type of forecasts which are issued, for example, here the map that you see, which is the probability of 2-meter temperature being above or below average. I want to stress the fact that these long-range forecasts are mainly issued in probabilistic terms. They're very difficult. We can only say something about the probability that something will happen. What you see here is, for example, that over Africa, this is the forecast issued on the 1st of October. For November, December, January, it says there is a high probability that Central Africa and Western Africa are going to be warmer than average, 60 to 100% probability of being warmer. In general, as you can see, there is a prediction of a warm weather. On the top left panel, you see another type of forecast diagram. This is the distribution of temperature over a specific area. In this case, it is over, I think, Southern Africa, if I remember correctly. Okay, more info are available, and some of these plots are available, freely available from the website of the European Center, where I worked for 27 years. Here is the link, here is the website. And with this, I would stop and give back the floor to you, Diana.
Okay, thank you so much. I do have a couple of questions. So you talked about seasonal forecasts being predicted, being done through satellites. And is seasonal prediction over Africa harder to do than other countries?
No, I wouldn't say so. So seasonal prediction is more difficult than prediction for the next days. But if we talk about seasonal prediction over the globe, there are certain regions which are easier to predict. And these are usually the regions in the tropical area. Why is that? Because this seasonal predictions are very much affected by the sea surface temperature. Teferi, for example, is an expert in looking at the link between sea surface temperature and weather. And if you're able to predict well the temperature over the tropical band, you can predict seasonal, we can issue good quality seasonal forecast over that area. For example, Europe is instead a difficult area to make seasonal prediction, much more difficult, because it's influenced by many factors. What's happening over the Arctic, over the northern latitude, what's happening over the Atlantic, what's happening over the southern part. So Africa is not more difficult than other countries.